Hi guys, welcome to lesson 10.3, operations with radical expressions. So operations, as Miss Zerzo kind of drew in there, we've got addition, subtraction, multiplication, and...
Are we doing division?
We'll do division eventually. So we're dealing with operations using these radicals. And our objectives for the day are simplifying sums and differences of radical expressions and simplifying products and quotients of radical expressions. So problem number 1 for today is going to be combining like radicals. And a like radical is when they have the same radicand.
My little think bubble. Do you like my think bubble?
Okay, so Ms. Zerzo has drawn in a little think bubble, thinking so we can think of these in terms of variables that we've dealt with before. But let's just rewind a bit. The same radicand is that number that is underneath the radical. So we need to have the exact same numbers underneath the radical. And now we are just combining like terms. So you can have 7 minus 8 times the square root of 2. So we're factoring out that square root of 2 in that problem to say, since it is a common factor in both terms, and now we just have 7 minus 8, which is negative 1, which reduces to the negative square root of 2. So we are just combining like terms here. So letter B, we have 5 times the square root of 5 plus 2 times the square root of 5. So 5 plus 2 is 7. And we rewrite the square root of 5. Okay, now this will only apply if they have the same radicand. All right, so letter C, we have 3 square root of 7 plus 11 square root of 7. Last time I checked, the square root of 7 is the same as the square root of 7. So we are adding 3 plus 11, and that is 14. 14 times the square root of 7. 9 minus 5. 9 minus 5 is 4, square root of 10. Remember that negative sign is attached to the 5, just like when we were doing combining like terms in semester 1. Make sure you pay attention to those negatives. For problem number 2, we are going to simplify by combining like radicals. But first, if we'll notice, problem A, we have 4 square root of 7 plus 2 square root of 28. Those do not have the same radicand. So we can't combine them, can we?
We cannot.
But we can reduce the square root of 28. Using our factor tree, we find that we've got square root of 7 times 4. 4 breaks into 2 and 2. So we've got 4 root 7. Plus 2 times 2, which is 4, square root of 7. Now we have the same radicand. Now we can combine like terms. So we have 8 square root of 7. Letter B, 5 square root of 32 minus 4 square root of 18. Looks like we're going to have to simplify both of these. So we break 32 into its factors. We've got 4 times 4 times 2. So there's a pair right there of 4s. So we'll have 20 square root of 2 minus 18 breaks up into 9 and 2. We've got a common set of factors with the 3's there. So 4 times 3 is 12 square root of 2. 20 minus 12 gives us 8 square root of 2. Letter C, 7 square root of 6 minus 2 square root of 54. Well, we're going to have to break that 54 apart. We've got 9 times 6. 9 breaks up into 3 times 3. That gives us our factor that we can pull out. And we've got the square root of 6 still. So we have 7 root 6 minus 6 square root of 6. Combine like terms, and it's just 1 square root of 6, or just the square root of 6. We don't care if you have a 1 there or not. It's up to you.
It's pretty much like saying either 1A or A.
Yeah.
Okay.
All right, letter D. 3 square root of 7 minus 4 square root of 63. 63 can be broken up into 9 and 7. 9 is broken up into 3 and 3. So we can take out a 3. So we've got 4 times 3 with the square root of 7. 3 square root of 7 minus 12 square root of 7 is negative 9 square root of 7.
Are we having fun yet?
The correct answer is yes, lots of it. All right, problem number 3, multiplying radical expressions.
This is where the fun starts. Hold on to your hats.
All right, so we are multiplying the square root of 2 times the square root of 6 plus 5.
Does that look
entire
familiar?
quantity. Hey, look, that looks like distributive property. Because it is. We're just using distributive property, and we're using our multiplication rules with radicals. So when we are multiplying, we just multiply the numbers underneath the radical sign. 2 times 6 is 12. So we've got the square root of 12 plus 5 times the square root of 2. Square root of 12 can be simplified into 2 root 3 plus 5 square root of 2. That is as simplified as you can go. They do not have common radicands, so we cannot combine those like terms, and they are both as simplified as they can be. And that's okay.
This is what we call simple math. That was funny.
Letter B, we've got the square root of 11 minus 2, the quantity squared. So if we remember, if we haven't beat this into your head enough, we
like
are
foil.
foiling. We're not just squaring each term, we need to use FOIL for this. First outer, inner, last. So we've got the square root of 11 times the square root of 11 is just 11. We've got minus 2 square root of 11 minus 2 square root of 11 plus 4. Now, why didn't I bother with the whole square root of 121? How did I just shortcut my way to 11? Because the square root of 121 is 11. And we know that the square root of a number times the square root of a number is just that number. So we have 11 minus 4 square root of 11 plus 4. And we can just combine our like terms. 11 plus 4 is 15. Minus 4 square root of 11. And that's as simplified as we can go. Okay. Letter C gets a little more complicated because now we've got coefficients involved. However, we are still doing the same process. We are simply foiling it.
We've seen this before.
Yep.
Only the numbers have changed.
Mm-hmm.
All right. Foil,
So,
foil, foil, foil.
all right, so 4 square root of 3 times the square root of 6 is 4 square root 18. That's the first. The outer square root of 6 times 3 square root of 6 is going to be 3 times the square root of 36. Okay. Inner negative square root of 2 square root 3 times 4 square root of 3 is negative 8 square root of 9. And our last term, negative 2 root 3 times 3 root 6 gives us negative 6 square root of 18. So now we can simplify and we can combine some of these like terms. I see we have 2 square root of 18, so we can combine those. They have the same radicand. Remember, the negative sign in front of the 6 is attached to it, so it stays. So we've got negative 2 square root of 18 plus 3 square root of 36 minus 8 square root of 9. Well, 2 of those we can simplify really easily. The square root of 36 is just
Oh, you started right here.
Oh, I did? Okay. So we'll do the first one first. Square root of 18 breaks up into 9 and 2. We have a pair of 3's in there. So we're multiplying negative 2 times 3. So we've got negative 6 square root of 2 and 3 square root of 36. Well, the square root of 36 we know is 6. So we've got 3 times 6, which is 18. And we are subtracting 8 times the square root of 9, which is 3. 8 times 3 is 24. So now we combine our like terms. 18 minus 24 gives us negative 6. So it's negative 6 square root of 2 minus 6.
The end.
That is our simplified form.
That is simplified.
All right. Now for problem 4. Rationalizing a denominator using conjugates. A lot of big words there, so let's walk us through. You're going to have to repeat this section a couple times and really make sure you practice it. So, a conjugate is the sum and difference of the same two terms. The product of a conjugate is the difference of squares. So remember how when we dealt with the difference of squares with factoring, we're doing the same thing here. So our example, the square root of 7 plus the square root of 3 and the square root of 7 minus the square root of 3 are conjugates. They will simplify to the difference of two squares. So it's 7 minus 3, which is 4 when we multiply them together. Okay, so let's take a look. Let's just work on a couple of these. Mathematicians do not like square roots in the denominator, so that's why we need to use these conjugates and get rid of them. So in order to get rid of something in the denominator, we need to multiply both the numerator and denominator by the same thing. So we're going to multiply by the conjugate, which is the square root of 10 minus 5, square root of 5. And we're doing that to both the numerator and the denominator. Make sure those signs are opposite. So when we multiply fractions, we first need to multiply straight across the numerator. So negative 3 times the square root of 10, negative 3 square root 10, minus negative 3 square root of 5. Should be plus, because it's negative times negative. I made it. It should be plus.
Where? Here?
Yeah.
Okay, that's what I was thinking.
Yeah.
You lost a negative somewhere.
Yep. All right. In the denominator, we have the square root of 10 times the square root of 10, which is 10. Square root of 5 times the square root of 5, which is 5. And then we simplify. So we've got the negative 3 square root of 10 plus 3 square root of 5 over 5. And that is our simplified form. Okay, letter B. We've got 8 over the square root of 3 plus the square root of 11. We're going to multiply by the conjugate, so we need to do the opposite sign. So we're going to subtract those two. So we have square root of 3 minus 11 over the square root of 3 minus 11. So multiply our numerators first. We've got 8 square root of 3 minus 8 square root of 11 over, we've got the square root of 3 minus the square root of 11, multiply it all out. You've got 3 minus 11. So now we've got 8 square root of 3 minus 8 square root of 11 over negative 8. Well, wait a minute. I got an 8 in every term there. We can cancel that out. So we're going to remove the common factor of the 8 from each of the terms.
which really looks like this. If I factor out an 8, I'm left with, and if I factor out,
And you'll still have a negative 8 down below.
which
And-
turns into a negative 1.
Yep. 8 divided by negative 8 is just negative 1. So we have negative square root of 3 plus the square root of 11. Okay.
Are you having fun yet? I know we are.
Woohoo!
All right. Letter C. We've got the square root of 3 over the square root of 21 minus the square root of 15. So we multiply by the conjugate, square root of 21 plus the square root of 15. All right, so we've got multiply it out. Remember, we need to multiply the numbers underneath the radical, and I just kind of
Oh,
automatically.
you shortcut it all
I
over. We're not
shortcut it
doing
all
that.
over the place. I like shortcuts.
Yeah.
That's just the way I roll. So we've got the square root of 63 plus the square root of 75?
That's a 4.
Okay, thought so.
Sorry, writing like Boland.
All right, square root of 45 over 21 minus 15. So now we can break our, we're going to have a reverse factor tree. We can break 63 up into 7 and 9. So we'll have this 3 times the square root of 7. And 45 can be broken up into 9 and 5. So we'll have 3 times the square root of 5. And it's all going to be over 6. Are we as simple as we can go, though? Can we factor something out of that?
Oh my gosh.
Do you want them to go that far?
Yes.
Okay. So we can factor out a 3 from both of those terms in the numerator. And we've got a 6 in the bottom. When we reduce that, it's going to be the square root of 7 plus the square root of 5 over 2. Now we are simplified. So like I said, guys, this is going to be one of those lessons where we need to practice it. We need to take our time. We need to watch these lessons over. We need to learn these rules and really get them solid in our brains. We are going to be practicing for the next 2 days in class on this topic, so we will have plenty of time to answer your questions. See you all tomorrow.